This is our video for lesson 2.2, and this is where we're going to start solving inequalities using addition and subtraction. So remember, if we have an inequality, that means we've got either less than, greater than, less than or equal to, or greater than or equal to. So that means we're using one of these four symbols in our equations instead of an equal sign. And so in the past, when we were solving equations, we had a couple different things we would look for. We would look for distribution, combining like terms, and then when we wanted to get that variable by itself, we would use inverse operations to isolate the variable. So that means just doing that opposite. So for example, we would look at something like x minus 3 equals 6, and then to get that variable x by itself, we would do the opposite. So since that was a minus 3, we add 3, which is the inverse operation, and that's what makes that go away. But if I do that to one side of the equation, I have to do it to the other. And this is exactly what we're going to do with inequalities. So this, in some ways, is very much review. So this would end up being x equals 9. So again, we're treating it the same way we did when we had an equal sign. Now we just have an inequality. So we're going to end up with more than one solution instead of just a single. So for example, this is very much like what we just looked at up above. I'm going to rewrite here just because I think that makes it easier to see what's going on. It's not equal to, it's just greater than. So again, my goal is to get the variable by itself. And so to undo this minus 6, I have to add 6. And what I do to one side of the inequality, I also have to do to the other. So I end up with x is greater than negative 4. And we're also going to graph these because they have more than one solution. And so we've just got we're going to graph these on a number line. And the only value that's really important in this number line is this negative 4. And so we can put that wherever we want on the number line. And we found that x is any number greater than negative 4. So if we're talking about greater than on a number line, that's going to be to the right. Right? All of the values to the right of negative 4 are greater than negative 4. So we're going to be shading to the right. And at negative 4, we have to think about, is this value included or not? And in this case, since it's just x is greater than 4, not greater than equal to 4, that means that negative 4 is not a solution. Only those numbers greater than negative 4. So that means that we have an open circle, and then we're shading everything here to the right. And we talked about that open circle versus closed circle in the previous section, so if you're not understanding that, I would go back and look at that previous section. So what this means, a reminder, what this means is we're shading this because everything over here, any number greater than negative 4 is a solution to our inequality. That means it would make this true. If we go back to the original, and instead of x, I substitute any value greater than negative 4, it would make this true. So for example, I'm going to just kind of, actually, how about I do this? I can just kind of move this to the side for a second, and then I'll bring it back. So if I were to plug in for x any value greater than negative 4, it's going to make this true. That's what we mean by it being a solution. So instead of x, if I put negative 2, because remember, negative 2 is greater than negative 4 on the number line, that would be like over here. So negative 2 minus 6 is negative 8. Is that greater than negative 10? Yes, it is. So since it makes our inequality true, it is a solution. But we could plug in anything. right? Think about all of the numbers that are greater than -4. 0, 2, 5, 100. Any of those would make this true. So for example, 0 minus 6 is -6. Is that greater than -10? Yes, it is. It's to the right of -10 on the number line, therefore it is greater. So if you need to kind of pause and think about that for a minute or go back to some other examples, I would recommend doing that because that's a really important idea that's going to come back when we're doing all sorts of other graphing as well. Okay, moving on. We're going to move a little bit more quickly now that we kind of got some of those basic ideas out of the way. So example 2a, I've got y plus 8 less than or equal to 5. Again, my goal is always to get that y by itself. And so I'm going to do the inverse here. I'm going to subtract 8 from both sides. Y is less than or equal to 5 minus 8 is -3. So let me think about just space here. Got my number line. My key point there is -3. And if y is less than or equal to that, all the values less than -3 are to the left, and if it's equal, we're going to use a closed dot. Next, we've got -8 is less than, not negative, 1.4 plus m. So in order to get that m by itself, this is a positive 1.4. So I'm just going to have to subtract that from both sides. So I've got minus 1.4 minus 1.4. So 1.8 minus 1.4 is -9.4, and that is less than m. So I always like to think about these when I go to the graphing. I always like to think about it from the perspective of the variable, right? Because those are the solutions, right? Whatever numbers I can plug in here for m that make this true, those are the solutions. So yes, if we were reading this, I would say -9.4 is less than m. But when I'm thinking about the solution set, I'm always going to think of it as m is greater than -9.4. So when I graph this then, I've got -9.4, and m is all of those values greater than it, but not equal to. So our solution set would look like this. Number 3, we're going to write as an inequality. So this is from 2.1, and then we're going to solve, which is 2.2. So this would be a good opportunity to kind of see if you can put everything together, pause the video, try to write this out on your own, and solve. And it doesn't say to graph, but not a bad idea to give that a try too. All right, so a number n minus 4 is greater than or equal to 12. Reading left to right, translating left to right, and then I'm just going to solve. Got n minus 4, so to get just n, I'm going to add 4 to both sides. N is greater than or equal to 16. And since it only takes me about 5 seconds to graph this, 16, n is greater than or equal to, our graph should look like this.